Thin Lens Lab, I'm going to walk through how to calculate the overall error on any one of your measurements. And what we're going to do is we're going to take your first measurement. Now, I've just made up numbers here. This may not be at all like what you have. But we're going to take your first measurement and we're going to just take it and we're going to go to a completely new sheet. Stick it in there. All right. We're going to a completely new sheet because we need to do a whole bunch of work with this little bit of data to get us to what is your error on this measurement. One of the things we had you do is we had you measure object position, lens position, and image position because these are three completely independent variables that are only connected by the physics. So if you measured object distance, that depends on both lens position and object position. And if you measured image distance, that depends on image position and lens position. And the lens position error correlates the two different measurements. Or anti-correlates them in this case. As one gets bigger, the other gets smaller. So here we are. We're going to go out here and the first thing we're going to do is we're going to calculate the focal length of the lens, right? So the focal length of the lens, we're going to get that from what? Well, let me pop up Excel. We have our lens equation, 1 over DO plus 1 over DI is 1 over F. And we want the focal length, so we're just going to solve for the focal length, which is going to be the focal length. Now, let's keep in mind, DO is what? X the lens minus X of the object, right? And DI is X of the image minus X of the lens. Now, if you have your coordinate system turned around the other way, just take the absolute value of these. That's all well and good. So the focal length of the lens in terms of these variables is going to be 1 over X lens minus X object plus 1 over X image minus X lens, all inverted, right? So that's the equation we have to build in Excel to tell us what the focal length of the lens is. And we're going to compare that to the actual focal length of the lens. I don't know if this one came out at all. I think I stuck in 20 centimeters as a focal length, but let's go over here and calculate focal length. 1 divided by lens position minus object position plus 1 divided by image position minus lens position, parentheses to the minus 1. Alright, and I get a focal length here of 17.5 centimeters. Alright, so I'm going to go ahead and make that font size a bit bigger so it's all nice and pretty. Alright, now what's the error on this measurement? Alright, the object position has some error, the lens position has some error, the image position has some error. So what's the error on this calculated quantity, the focal length? Well, if you know partial differential equations, we could go through and calculate that. But that's the topic for beyond the calculus sequence. So what we're going to do is something completely different. First, I'm going to copy this data. Now, I'm going to copy, no, I don't need to copy. Alright, we're going to do 2 lines here. I'm going to use formulas everywhere. So the object position equals the original data, well, here, plus the error on the object position. This equals that. Alright, and once I'm there, the rest of these I'm going to leave alone. They're just equal to their original values. I'm going to go out here to the focal length, copy that equation, paste it there, and so this is the focal length if our object position is off in this direction. Right? Now I'm going to take the same thing. I'm going to go up, take my object position, and I'm going to subtract the error, right? And then across here, these are all going to be the same. Apparently, I need to make sure I'm at, let me just grab the whole sheet. Let's go to Arial and 12 font everywhere. So we've got some uniformity. And I'm going to copy this equation again, right? Okay, I'm going to say that the error, right? Here we've gone up, we've gone down, and so object position error, I'm going to take to be the absolute value of the difference between these two, right? Because that kind of covers our full range divided by 2, right? So this is the error on this measurement due to the object position. All right, let's take another shot at it. What are we going to do now? Well, we've evaluated one error, right? Now I'm just going to go up and I'm going to say this equals that, this equals that, and we're not messing with the object position now. Now we're messing with the lens position. So the lens position, I'm going to go up and say lens position is this plus the error. I'm going to come down here and say the lens position is this minus the error, right? So those are I'm up one error, down one error. I'm going to go over here, calculate, copy these, go there, right? And this is the lens position error. Right? So this number right here, 0.02, is the error on this central measurement due to our understanding, the error in our understanding of the lens position. All right. So far, so good. I hope you can always rewind and go back through. We've got one more to do. We've got to do the image position. So image position. Again, for most of this, now you're like, why are you using the formula? Why aren't you just calculating it? I mean, why aren't you just copying and pasting? I'm going to show you in a minute when we do the next page. And now, of course, the lens position, or the image position, we go up, we add in the error, we go up, we subtract out the error, right? Okay, copy these. And now we have the error in this measurement due to our understanding or lack of understanding of the position of the lens, the position of the image, sorry, right? So the error, the image position error, lens position error, object position error, these are all the errors that contribute to this overall focal length and our uncertainty around it. Now here's the beauty of how we've constructed this experiment. Object position, lens position, and image position are all independent. So if these were independent coordinate systems and you wanted to determine the distance you would travel in them, you wouldn't just add these numbers up, you'd be calculating what's the length of the hypotenuse connecting two different points. And so the total error due to the measurements on this page, we take as the square root of this one squared plus this one squared plus this one squared, right? We square all of the errors, we sum them, and we take the square root to get to our total error of 0.476 centimeters, right? So the proper statement on this measurement is it is 17.479 plus or minus 0.476 centimeters. All right, that'll be important for your lab report. We're going to want you to calculate that for each of your measurements. Now you're like, oh, I have to do that for each of the measurements. Here is why I had you set this whole thing up this way. I'm going to go down here. I'm going to rename this to 200 millimeters. All right. I'm going to copy it. Move or copy, create a copy. I want that at the end. All right. I don't know what this should be named. Probably 250 millimeters, 220 millimeters, but we'll worry about that in a minute. All right. Now I'm going to go back to the 250 millimeter line. Of course, you can see when I made up my data, I completely ignored this. I'm going to go back. I'm going to copy this line. I'm going to go over here. I'm going to paste it in. And all of those changes, all the changes in this data, automatically propagate through, right, to the error due to the image position here. Right? I don't have to do any more calculations. I set up all the calculations to be done automatically. Now all I have to do is create a new sheet, put in the new data along the top. I don't touch anything down below. It automatically ends up calculating it down here, and I can very quickly calculate all of my errors that I need to calculate in this spreadsheet. Hopefully that answers or tells you how to do this. Hopefully you can follow along without much problem. If you have any questions, don't hesitate to send me a note. All right, good luck, and I'll talk to you later.